Good morning, Heath.
Hey, Ramos.
How are you doing?
Nice to meet you.
Likewise.
So, I saw that you wrote in about a generator. You want to tell us a little bit about what you got going on?
Yeah, so we just moved here less than 2 years ago.
Okay.
And because of just the trees around us, we lose electricity a lot. So
I can see that.
my father-in-law was generous enough to give me a generator.
Okay.
I just would not like the idea of connecting it with extension wires to like the fridge, for example.
Well, I appreciate it. I'm glad you want to do it safely.
Yeah, I'd love to like connect it to the panel, but I don't feel comfortable doing it.
Okay, so it looks like we have a good portable gas-powered generator here. We have a newer electrical panel. It's going to give us some flexibility as far as connections.
That's great.
But there are a couple of things we want to keep in mind. So we want to have this generator outside.
Okay.
We want to get the exhaust aimed away from the house. We want to make sure we don't get any carbon monoxide coming back in. So in order to do that, we want to connect it from the outside and then feed back to this panel. So we really have a couple of options that we can do this safely with. So let me grab those. We can take a look and go from there.
Perfect, thank you.
All right, Ramos, let's go over those two options I was talking about. So the first one is a conventional transfer switch. Now how this works is we tie all these circuits to the panel, but we have to pick a certain number of circuits. So we're going to want to pick your heating system, refrigeration, certain lights, things like that. And then when it comes time to use it, you pull the generator outside, cord connect it, start it, and then you simply flick from line to generator.
That's it.
One at a time. Powers up what you chose, like refrigeration, heating, some lights, that kind of thing. When you're done, the power comes back on, turn them back to line, turn the generator off, unplug it and put it away. Simple, nice and easy. The disadvantage is you're limited to the number of circuits. Okay. So you have to pick what you want to have in the house. You can't run everything. You're not going to have lights everywhere. You're not going to have receptacles everywhere. So just be aware that is a limitation.
Okay.
The other way to do this is with a mechanical interlock. And what this does is it's a little bracket that goes over the main breaker, and we install, in this case, a 2-pole 30 breaker that's going to let the power come in from the generator to the panel safely. So if we're looking at the interlock, when you use the interlock, in this case the main breaker would be here, and the breaker that's providing the power from the generator would go here in your panel. So here the main breaker, we'd turn this off. This would allow this bar to slide over. When that slides over, we can then move this one. This lets us turn the generator breaker on. Now the main can't go on because this will prevent this handle from sliding while this is on. When the power is restored, we want to go back to utility, turn this off. Now that goes back over. This can't move and the main can go back on. When you do this, you have the flexibility of turning on everything in your house. Lights, receptacles, so you're living like you normally would for the most part. But the drawback is now you have to pay attention to what you're running. You can't run anything too big. No electric ovens, electric dryers, central air conditioning units. Based on the generator you have, you only can run so much, but you can still walk throughout the house and treat it like normal.
So what will happen if I overload the generator?
You'll hear it. The generator will bog down, might stall it, might trip the breaker that's feeding it. It all depends. So you really want to try and avoid that.
Okay.
And the last thing we're going to look at is how we connect it. So we're going to have a power inlet box, they're called. We're going to mount on the outside. 2 ways to go, one with that front and one with the bottom feet.
Okay.
We have this cord that's a twist lock cord that plugs in, twists, just like the name says, and doesn't come out. So once it's in there, it stays, will not release until you untwist it. My preference is this way. When you're installed like this is still exposed to the weather a little bit. If we're in a bad storm or something, the cord's coming straight out, it's a little more stress on it. If we install it like this and the cord's hanging from the bottom, it's twisted into place, it can't come out, it's completely protected from the elements. I feel a little more comfortable with this one.
I agree with you. That sounds like a no-brainer.
So we have the cord, we have that. Which way do you think?
I really like the flexibility of the interlock, but I'm scared that with sleep deprivation, with 2 kids,
Sure.
that I would do a mistake. So I feel probably more comfortable with this, and I think my wife would be probably like more comfortable just putting on just some switches.
Starting it and then just throwing these switches. Yeah, I think it's a little bit easier, and I think you have enough in the house that we can make this work and be comfortable for you.
Great.
All right.
Yeah.
Let's get to work.
All right.
Dave from the electric company is here to make the disconnect. He will start by removing the cover from the meter socket, removing the meter socket itself, and then testing the terminals. Once he's sure that there's no power that's going to pass through, he'll cover it back up, put a blank plate on, and lock the system out. This will allow us to work on the panel without it being energized. Next, I want to mount a piece of plywood to the wall, and I want to attach it to the studs to ensure I have a safe and stable mounting area for the transfer switch. Now, I painted it black because I think it looks a little nicer on the wall than just a bare piece of plywood. Then, I'm going to connect the flexible conduit that comes with the transfer switch to the panel. This is going to give us the length of where the transfer switch is going to land so we can locate where it's mounted. The wires in the transfer switch are marked by letters. Here we have 2 wires marked with the same letter. One wire is going to go to the breaker, and the second wire is going to take the wire that came off of the breaker, wire nut to it, and go back to the load inside the house. We want to drill through the shelving system with a hole saw to get our conduit through. Next, I need to run a conduit from the transfer switch to an external power inlet box. I'll need to be a little creative here since there's a set of deck stairs on the other side of this wall that I don't want interfering with this inlet. Instead, I'll try to run the conduit through the holes I've drilled in the garage shelf and mount the exterior inlet on the underside of the stairs. This location will work nicely too because the generator can be placed next to the condenser when it's being stored, so it looks like it's always been there. All right, Ramos, well, now we're actually at the point that we can test this. So we've gone and made all the connections to the electrical panel. Transfer switch is completely done. We've installed the outdoor power inlet right there, and we've located the generator where we want to put this that's level, on pavement, out of the way. And what's the most important thing?
The muffler away from the house.
Exhaust is going away from the house, exactly. And we have it at a pretty good distance. We've got a 25-foot cord here, so we should be pretty comfortable.
Okay.
So what I want to have you do is do the entire process. I'm going to start by having you connect this cord to the power inlet over there.
Right, thank you.
And remember, it is a twist lock, so you're going to push that up and just give it a little twist clockwise.
Okay. Okay, I'm good here.
Good. All right. And same thing on this side. I just want to have you do all of it so you're comfortable. Same thing into that receptacle on this side. Good. Give it a little tug. Great. Let's start it.
Okay.
Beautiful. Generator's running smoothly. Everything's connected. Utility power's still off. So let's go inside and transfer over. Okay, so now the hard part's done. We're all connected. We're up and running. Here's our switch. And you can see that all of these right now are down in the line position. Okay. Line means the utility, the power coming in from the street. Since we don't have that, all we have to do is simply flip these up to generator and you'll be on generator power. So
awesome.
All yours.
Thank you, sir.
Just like that. House is on generator. Everything's working.
That's awesome. Heath, I can't thank you enough. You did a fantastic job, and I think it's going to be very easy for me and my family just to turn on these switches and turn on the generator, and we're going to be okay.
Perfect. That's what we want. So let's go outside. We'll kill the generator, put everything away so you can get to it in the future, and I'll stick around and wait for the utility company.
All right, sounds good. Thanks.
Thanks for watching. This Old House has got a video for just about every home improvement project, so be sure to check out the others. And if you like what you see, click on the subscribe button to make sure that you get our newest videos right in your feed.